right, in this section, we're going to use the skills from the last section. We did a bunch of factoring, and we're going to simplify some algebraic fractions. So this is not unlike simplifying or reducing a numerical fraction. So just up here in the top margin, say, if I wanted to reduce the fraction 15/24. One way to do it, and this is the way I'm going to encourage you to think about it because it translates directly into how we do it for algebraic fractions, is I'm just going to start by factoring 15. That's 3 times 5. 24 we could factor as 3 times 8. And now we have a common factor of 3 on the top and the bottom. We can cancel those out, and we're left with 5/8. And 5 and 8 have no common factors. There's nothing more we can cancel. So thinking, if we kind of take this approach, the simplifying an algebraic fraction works the same way, like exactly the same way. So we're just going to start by factoring the top and the bottom. Now in this fraction, in example 6.9, the denominator is already factored, right? We can't, x plus 4 cannot be factored further. Up top, though, we could take out a common factor of 2x. And when we take out a 2x, we're left with x plus 4. And now we have a common factor on the top and the bottom. The bottom is really, we could think of it as x plus 4 times 1. And this is important because I'm canceling a common factor of x plus 4. We're not canceling over addition here, right? The addition is happening inside that factor. So x plus 4 times 2x on top, x plus 4 times 1 on the bottom. We can cancel that common factor and we get 2x. In the bottom, or sorry, in this next example, we can factor both the top and the bottom. The bottom is a difference of squares, so that could factor as x plus 2 times x minus 2. Up top, we got to unfoil this. So we need an x and an x, a minus 2 and a minus 2 will work. That'll give us the plus 4 at the end, and it'll give us the minus 4x in the middle. Now we have a common factor of x minus 2. The only, there's subtraction, but that subtraction is all happening inside this common factor. So we can cancel that out. We're left with x minus 2 over x plus 2. This is as far as we can go. We cannot cancel over addition. That means we cannot cancel the x's, we cannot cancel the 2's, because those are separated by addition and subtraction, right? So that's different than when we canceled this common factor of x minus 2. The subtraction happened inside the factor itself. Let's do another one. In the bottom, that is something that we can unfoil, I think. So we need a y and a y to give us y squared. The last two terms have to multiply out to 4, and the inside-outside products have to give us a plus 5y. So that would be plus 4 plus 1 will work. Up top, it's a y cubed expression, but notice there's actually, we could take out a common factor of y first. So I'm going to do that. That leaves us with 3y squared plus 7y plus 4. And then what's left there is a quadratic, is a trinomial that I think we can unfoil. So to get 3y squared, we'll need a 3y and a y. To get a plus 4, notice it's a plus 7y in the middle, so I think we'll need a plus and a plus. And then we need to get a plus 7y, so I think 3y plus 4 and y plus 1 will work. That is, let me do a quick check, that's plus 4y, and that is plus 3y, which gives us the plus 7y in the middle. Now we can cancel common factors. And we have just one common factor to cancel. It's the y plus 1 and y plus 1. We are left with y times 3y plus 4 over y plus 4. There are no more common factors. I cannot cancel the y. We have a factor of y up top, but we don't have a factor of y in the bottom. In the bottom, y is just a term. So it's y plus 4, not y times 4. I can't cancel the plus 4 because I can't cancel over addition. So this is as far as we can go. Occasionally you might see factors that differ only in sign, or what you might run into are like where you see what looks like it could be a common factor, but the order of subtraction has been reversed. And so that is a factor that differs only in sign. So we start just with this observation, this fact up here, that the negative of x minus y, if you distribute the negative and rearrange terms, is the same as y minus x. So I'm going to start by, in this next example, we can't really factor the bottom, not in the usual sense, because it's just 1 minus x. The top we could definitely factor. That is a difference of squares, so that's x minus 1, x plus 1. And then, we kind of focus on the fact that we've got these two factors that look awfully similar, right? X minus 1, 1 minus x, they're so close. They are not equal, so I can't just cancel. However, I can use the fact up top and say, well, this x minus 1 up there, that's the same as negative 1 minus x. And you could choose to do that with either of those two. I've chosen to do it up top. If you do it with both, it won't help. You'll still be in a position where they're not exactly the same. So now we can cancel the 1 minus x common factor. When I cancel, you notice I've got nothing left on the bottom. That means I actually just have a factor of 1. Anytime you cancel and everything's gone, like you've canceled everything out, that means you still have a factor of 1. So this is negative parentheses x plus 1 over 1. Now usually we wouldn't write over 1 if it's a fraction that's over 1. That we usually just don't write it as a fraction at all. So we'd write this as the negative of x plus 1 or negative x minus 1. Either is okay.